Sir has already delivered an informative presentation and benefited us all on the second day of the AICTE training program. Without further delay, may I now request Dr. K. Nanthakumar, sir, to kindly take over the session. Thank you, and over to you, sir.
Thank you for your nice introduction. So, very good morning to all, dear friends. Uh, yes, just I am sharing my presentation now. Professor, can you see my presentation now?
Yes, sir, it is coming, sir.
Okay. So,
Yes, sir.
yeah, please. It's visible now?
Not yet visible. So slides is shown, but it is only in white color.
White color.
Means no image is there. So you move the slides.
Yeah, just a minute. Now?
Yes, sir, it is coming now.
Professor, is it visible now?
Visible, sir, visible.
Okay. Okay. So already we have discussed about the different waste which is generated from various process during downstream process. I mean upstream, midstream, and downstream process. Particularly focused on upstream process. What are the waste, different kind of waste which is generating from upstream? I mean oil well exploration and production process, and what are the different approach or methodologies or methods available which can manage without producing any secondary waste or secondary pollutant from the process. So today, based on the previous presentation and no, it's a continuation with that, I would like to discuss about the waste management in oil industries, particularly oily sludge and hydrocarbon based waste material. So here, being a biotechnological background expertise, so I like to focus mainly on the bioremediation approach, which is also conventional as well as a very old method, and it has emerged as a new modified method or integrated method, which is applied throughout the industries. And now also industries also more interested in this kind of technology, wherein there is no secondary or further pollutant is produced from these kind of technologies, particularly biotechnological approach. So here, just before going into the bioremediation process, again, oil industries, we have mentioned about the downstream, upstream, and middle stream, midstream process. In all stages, there are huge quantity of stream, the oily sludge or oily material, water mixed with oil. Such kind of waste is generated during the upstream process, during the drilling process, as well as during the transportation. Also, there is the chances of oil spill, and there is the no replacement of oil pipeline, and there also there are sedimentary waste which is also coming out from the pipelines and during the transportation. Then in the downstream process, in the refining process and in the purification process, again there are also lot of no around 3 to 5% of residues which is also settled in the storage tank. Again, that need proper disposal. So in upstream, midstream, and downstream, there is a significant quantity of oily sludge or oily hydrocarbon-based waste. So so we have to find out the solution, or we have to apply the appropriate technology to manage these waste. So so significant waste, what are all the waste it is generating? Mainly the drilling cuts and even a lot of produced sand, no metals, organic waste, produced waste, water, so solvents. But many of it has no. We can go for the recycling process, but recycling are a kind of disposal process. But these oily sludge and oily water that can be treated completely, and we can either, depends on the contamination level, either we can go for the recovery, I mean recovery process, or we have to go for the treatment process. So again, there are also lot of technologies which is currently in practice. So like physico-chemical methods and conventional method is available. So we can use any method which is suitable for the treatment of such kind of waste. So here I like to mention there are different kind of treatment method which is available for the oily sludge, oily water, or oil contaminated soil. So there possibilities like already we have discussed pyrolysis process, how waste material can be oily sludge or oily water can be oily sludge, mainly solid content, which is a semi-solid material, which can be treated through either physical process or biological process. So biological process we will be going to discuss in very detail. And in case of by a physicochemical method, like physicochemical method is, for example, if you go for this soil washing or kind of solvent extraction, solvent separation process, again no waste, that is a secondary waste or kind of air pollutant. So emission from this during the treatment is more. So now industries or no agencies, they are looking for the kind of eco-friendly process which should not produce any kind of pollutant during the treatment process, or it should not produce much significant secondary pollutant or byproducts from the treatment process. So in that case, compared to soil washing or kind of pyrolysis method, where huge amount of air pollutant is generated, again during the soil washing kind of physical process, again a lot of sludge is generated. So so that kind of material treatment technology have its own disadvantages. So many years, a group of scientists worked on such kind of biotechnological interventions. So and develop and keep developing kind of a single or combined process or sequential process or integrated process along with the recent technological stages. So they applied and no, they did a lot of R&D in this area and come up with a complete process which can able to degrade and remove the pollutant from the environment. So this kind of technology, bioremediation or biotechnological treatment technology is applicable in any kind of waste. It depends on the concentration, severity, and type of pollutant present in the waste material. So when we I just want to focus on the bioremediation process, which is one of the technology applied in oil industrial waste treatment process. So, what is the bioremediation? This is a very no natural process. Bioremediation is a natural process wherein what is the bacteria or fungi, that is called microorganism, which degrade or remove the pollutant from the environment. So it may be a group of pollutant or in single pollutant which has its own toxicity level in the environment, like soil, water, and other environmental matrix. So there, these natural bacteria or fungi, which is have the very good mechanism to uh, secrete kind of enzyme that degrade or remove this pollutant from the uh, environment. So bioremediation is one of the clean technological approach to clean up the oil spill or contaminated groundwater. So the form of bioremediation product which is developed, and you can use it in either in the oil spill or oil contaminated soil or groundwater also. So there is a method for each stage of cleaning and process. So how this bacteria act upon the pollutant and how it degrades and what are the conditions, so that is also very important. So many kind of bacteria which is naturally occurring in environment, so this has both the depends on the factors surrounding environment, it become like kind of pathogens, that is that we have to categorize it. And there is a huge number of beneficial bacteria which can degrade or remove these pollutant that we are using for the bioremediation process. So these bacteria generate a kind of excretion of extracellular enzymes. So these enzymes in specific condition, in specific environmental condition, these bacteria, this beneficial bacteria generate the enzymes which act upon the complex product like oil, hydrocarbons that depolymerize these polymers into monomer, that is a simple form. So once it is simple form, it may be again toxic also, that we have to study systematically, and any other second class of bacteria or fungi or any other system have to be applied along with these group of bacteria, so that that toxicity can be reduced. So there is a systematic approach to identify the bacteria and group it and have to make a kind of product, then we can apply it. So all bacteria can't degrade all kind of components. So there is a requirement to identify the specific bacteria which can able to degrade specific compounds, and the end product or intermediate can need to be managed systematically, either for using the bacteria or any other microbes or any other method. So integrated method is there we can apply, or a group of bacteria also can be applied as a consortium, so that each bacteria have their own mechanism or secretion process, that is a enzyme secretion process, so that we can target and degrade the hydrocarbons completely. So again, these bacteria also convert this pollutant into end product like CO2, water, and other end product under different conditions. Like under aerobic condition, bacteria which excrete the enzymes that polymerize the compounds and they convert into CO2, H2O. So there won't be any secondary pollutant or secondary product released from the process. When under anaerobic condition, again bacteria convert these uh, pollutant into methane, CO2. So again there is a application. So here environmental condition is again very important. So when we go for the aerobic condition, so the degradation process will be high and the end product also it will completely degrade. So according to the bacteria, according to the pollutant and the secretion of enzymes. So all these conditions as well as the bacterial nature and its characteristics very important to select the appropriate product or microbes for the bioremediation process. So each category have pollutant have its own properties. So selecting the bacterial consortium or product is very important to achieve the complete degradation of the product. So these are all the basis of bioremediation process and how it is acting on the pollutants. Then what are the factors, both the abiotic factors and biotic factors? Like abiotic factors is micro moisture content, temperature, pH, and aerobic conditions. That kind of factor is very important, because when we maintain these pH, ideal pH, to enable the biodegradation process is very important. Same way for temperature, because there is a category of bacteria which have the capability or genetic, its structure and genetic makeup is such a way it's managed to tolerate low level of temperature or medium or high temperature, so that the thermophilic bacteria have its own no makeup, genetic makeup to tolerate a high temperature range. So same way for pH also, and moisture also. We have, so ideal moisture need to be maintained in any process to enhance or to activate or kind of maintain these bacteria in the active form to secrete the enzyme to degrade the pollutant. So managing the abiotic factor and biotic factor in the treatment system is very important to achieve the final product, that is a complete degradation of the pollutant. So, and also the polymer, what are the actually, and also degradation is also based on the characteristic of polymer or complex material, its molecular weight, size, and what are the additives. So such kind of characteristics also influence in the bioremediation process. So these are all the small outline I have given about the how bacteria act upon the pollutant and how, what is the mechanism behind it. This is a generalized system which is applicable to any kind of pollutant. It may be a pesticide, it may be PAH, it may be a total petroleum hydrocarbon, but the approach, what is the process, our background is, this is the process of degradation. When we come to the specific pollutant like oily sludge or oily wastewater, so again we have to see the pollutant characteristics, that is total petroleum hydrocarbon composition, which is in the form of crude oil, which has the alkane fraction, aromatic fraction, NSO fraction, and asphaltene fraction. So this alkane fraction have this straight chain compound, branch chain compound, and cyclic compounds. Whereas in the aromatic fraction, monocyclic aromatics, polycyclic aromatic compounds, both it is in the form of aromatic fractions. So when we go for the developing the process or technology to treat these kind of waste, because this is the waste which is more hazardous than any other waste, because it required a lot of treatment technologies, methods, and time to dispose it in systematic way to achieve the legal requirement as well as to save the environment. So compared to any other waste which is possible to, either we can go for recycling or any other method to dispose it. But when these kind of waste, which is either you can't use for recovery of energy, then obviously you have to go for developing such kind of very effective technology to treat and dispose this hydrocarbon waste completely. So these crude oil, so initial stages we have to characterize the crude oil, what are the fractions there, these are the component within the hydrocarbons. So you have to study the TPH, that is the hydrocarbon degradation in laboratory level. So how we can select the bacteria. So this is the process of selecting the bacteria and efficient bacteria, that is the effective bacteria which need to be used in the process. So first step is we have to characterize the pollutant. Then second stage is have to select the effective bacteria or microbial consortium to degrade these petroleum hydrocarbons. So these bacteria, you can see the plates, which is a bacterial strain. These strains, either it may be isolated from contaminated site itself, because these bacteria have these when it grows in the contaminated site, it have its own genetic makeup to tolerate that such kind of pollutants. So it's a kind of adaptation in the environment, specific environment. So it's keep exposed in the same pollutant, so it has its own no tolerant gene in the bacteria. So again it secrete the enzyme and which is easily degrade that pollutant. So when it grows with such kind of same kind of pollutant present in the environment, so it have the efficient capacity to degrade that pollutant. So generally initial stage we used to select the bacteria from the same environment, so that all the abiotic factor which also suitable for that particular enzyme, bacteria. So example, when you found some huge oil spill or oil contamination in one particular industry. So what first stage is we can select some bacterial strains within the specific environment. Then we can cultivate in the laboratory and we can check for the enzyme production activity and what are the molecular characteristic of the bacteria, and how how efficiency of this bacteria in degrading these pollutants, same TPH from that particular same industry. So that type, then see these two photos, you can see this is the bacteria strike plated with pollutant, that TPH, total petroleum hydrocarbon from the industry. So this is a control plate without bacterial stain. First photo is without bacterial stain, only microbial nutrient in the controlled condition is poured with TPH, total petroleum hydrocarbon. Then second plate, that is a Petri plate, where you can able to see the batches, that is after degradation, that's residue we can see. So this is the difference. Initially such kind of laboratory process is required to select the efficient bacteria. Then after this we can extract the product and we can characterize it, what are the fractions present in the product and how it is reduced after treatment with that selective efficient bacteria. So this is the selection process, screening process, the way we can select the bacteria which is effective in degradation process. So alkane fraction, then we have to study systematically how it is degrading in alkane fraction, how it is reduced fractions in the hydrocarbons, and degradation of alkane fraction, how it is from the first one is controlled, then after degradation, after inoculation of bacteria, how it is reduced the alkane compounds. Then mineralization. So this is again the mineralization of alkane compound. Then aromatic fraction of total TPH, how aromatic fraction is removed from the TPH. So pH, again this is the alkaligens strains which is used for the degradation study. Controlled, so there is a intermediate product after degradation process, then that can be characterized whether it is toxic, non-toxic. If toxic, then again what is the alternate other strain we can use it. So like that we can replace the strain, and we have to find out how these bacteria are mineralizing these aromatic aliphatic fractions. Then sulfur containing compounds, again here also it is reduce that parental compound. So This is the general method to detect and identify the effective bacterial strain for the bioremediation process. Then how we can enhance this bioremediation process? There are advanced technologies. We can synthetic bioremediation strategies also we can enhance that. Functional genes, that is the responsible for the production of effective or specific enzymes that target the compound for the degradation. So that specific functional genes need to be identified in the effective bacterial strains, and that identification, then we can you hear me? It is disturbed now. Professor?
Yes, it's audible, sir.
Yeah.
Yes, sir. Yes.
Yeah. Then that functional gene can be introduced in the bacteria, which is easy to multiply in the laboratory. Then it can go for the application. So these genetic circuits or whole biosensor can be edited and inserted in the other easily growing bacterial strains that can become a group of consortium. Then that recombinant or metabolically active bacteria can be actively used in application of bioremediation process. So in this kind of enhanced method, you can avoid the production of secondary metabolites in the or toxic compound in the bioremediation process. So these are all the advanced method of enhancing the bioremediation process. So again, bioremediation process can be used in the ex situ or in situ method. That also again we will be going to discuss in later stage case studies. So here, these are all the fundamentals of bioremediation process and how it is working and what is the mechanism behind bioremediation process. We have discussed up to now. So after this, I will be going to discuss about the actual bioremediation process, how it is carried out from our team. As I mentioned in last presentation, so we have a kind of product which is developed by Terry, and it is used in different oil industries. So this is a very unique product. Even lot of product is available in the market for the different kind of pollutant, including oil, contaminated soil or sludge. So this is the one kind of successful product which is applied throughout the oil industries in India as well as in abroad. So that is called oil zapper. So this product is a kind of very unique bacterial strains which has a group of bacteria consortium which is used in treatment of oil contaminated soil as well as oily sludge. So this is the kind of facility we have in our production facility. So bacteria, already I mentioned how it need to be isolated, identified, then further characterized, and degradation studies need to be carried out. So like that, these bacteria consortium is developed, and in the lab, again each batch of bacterial production. So these bacteria, these identified bacteria are multiplied, are cultivated in such big 13,000 liter or 1,000 liter biofermenter. So you need a effective bacteria in the product form. So we can't just like because when environment is concerned, have complex form of pollutant as well as the adverse environmental conditions. So such to manage such kind of pollutant and environment, so we have developed this product in the laboratory scale, and it is upscaled, and produced in the large scale fermenter and transported to the field for application. So this is the oil zephyr product which is patented and is initially funded by DBT. So it is a very unique product which is used in the degradation of TPH. This is the facility we have, laboratory R&D facility as well as fermentation facility specifically. So we have the range of biofermenter from 1 liter to 13,000 liters. So for R&D, there is a separate requirement of fermenter, and upstream upscale process also. Again, we need a set of fermenters, and for the commercial application, that is the upscale process, upscale and development of the product, we have the set of fermenter for the production of product. So I'm just taking one case study wherein in myself and my team, and it's one of the very unique project from India, because one of the biotechnology product which is developed and funded by ministry, and it is successfully upscaled in big level, and it is applied in large scale application in Kuwait oil field. As well as in India, it is from 1996 onwards, this oil product is applied. So I'm just because only discussing about the theoretical work, it won't give much influence on the research aspect. So I like to here present one case study, which is a white oil field, how this product is developed and how it is transported, applied, and so each aspect is a very unique project, and it is almost 6 years of duration. This project is carried out, and it's successfully completed also. So the oil spill is a global problem. So there is even recently in Assam also there is a natural gas blowout from Dhrubajyoti. So there also, even our team, even myself, I have visited there, and we had a good field visit, and we have done the bioremediation work there is going on still. So such kind of oil spill or a kind of disaster or a kind of accident is very common, even though a lot of control measures taking place. So one such kind of problem happened in Gulf. That is a oil spill happened in Gulf War 1990. So during that time, lot of oil wells, maybe more than 100 oil wells burned out, and it was burning for a long year. So lot of oil spill. So it destroyed all environmental conditions, and it created lot of environmental issues there. So these are all the other accidents. Total contamination area, it is highlighted. So from that Gulf War, this highlighted zone is completely approximately around 114 square kilometer area is completely destroyed, and the oil spill happened. So Kuwait government, along with the UNCC, they come out with the project called bioremediation or remediation project. It is not only bioremediation; it is a remediation for the removal or management of these polluted site. So they want to restore. They want to restore this site to the previous condition. So they have given the project to various agencies to clean up this. So contaminated soil, they originally planned to dispose in the landfill, but again it have lot of advantages, because we need a huge land site as well as landfill site, as well as have to transport the material, and it is practically very difficult process. So then they made a total remediation solution strategy to uh, manage this waste properly. So for that, they planned for the different technology, identification of different technology for the remediation or management of these waste. So this is not a small quantity. It has more contaminated soil and oily sludge, oil, so undegraded or weathered material. So it is lying for more than 50, 60 years. So a lot of oil containing tar, everything is in, partially degraded and undegradable material also present. So based on the characteristic, so initially they go for the estimation of the area, what is the area, what is the quantity of waste which is lying in the area, and how what is the approach risk, what is the risk based approach, based on that how we can treat the waste. Less than 2%, either we can go for the natural phytoremediation kind of process, either 2 to 7%, which is ideally they use for the treatment through either physical method, chemical method, or biological method. And more than 7% TPH, either it can go for the recovery of oil from the waste. So based on that, they have allocated the contaminated site into block A, block B, and block C, and even control site, to assess the efficiency of various treatment technologies on the treatment of these different waste. So the first stage of the treatment is we have to characterize the site. So before applying any kind of technology, you have to demonstrate that, because these are all compound, these technologies are very specific, and also it depends on the pollutant, the success rate also different, because concentration will be different, and kind of composition also different. So we have to assess whether the selected product, like oil zephyr or any such kind of bio product, which is really have any efficacy to degrade. So characterize it, because these generally group of bacteria is isolated from some location, different location. It may not have same efficacy in different environmental condition. Like white is very harsh environmental condition. So we have to assess initially before applying the technology in the specific area. We have to study that location, whether this product is really efficient to treat that product. So, for that purpose, Terry have taken up the small trial in KOC Kuwait Oil Company, and they transported the product and apply the oil zephyr in the trial field. It's a very small area. So they prepare the nutrient mixture. That is a part of product. Then they maintain the conditions to may enhance or maintain the remediation environment. I mean, suitable environment for the remediation. Then the rate, that is the in different that block, that is a kind of executive study only. So there are different blocks in control block, and different treatment blocks it is maintained, and after every frequent interval, the sample has been collected from the site and it is tested. So within 60 days, there is a huge reduction, more than whatever the initial contamination is reduced to less than 0.5%, which is a requirement for the remediation of TPH pollutants. So again, that after remediation, again a quantification has been carried out. That is, a total petroleum hydrocarbon is estimated using US EPA method, standard method for the estimation of TPH, and again that end product again characterized initial 0 day and after 60 days. So from this slide, you can see the reduction of alkane and aromatic fraction in the block A. So how 0 day, what are the aromatic fraction is present and how it is reduced after 60 days. So initial trial, then after completion of the remediation with the application of appropriate bacterial strains, that is oil sulfur, with the required number, that is the bacterial, maintaining the bacterial population is also important to manage and complete the bioremediation process, so that all the bacteria will degrade or eat these hydrocarbons in the soil and it convert into fertile soil. So after that, after completion of the degradation process, again soil is tested, and again after testing again characterized, then degradation compound also tested. Then after achieving the remediation standard, this is less than 0.5%, then that site again tested for its toxicity, whether it is supporting the growth of plants or natural life. So the you can see this various plants and vegetables are grown. So it indicates that this soil is back to normal condition that can be used for any other purpose. So it's a free of hazardous material. So based on that, Terry got a very big mega project from Kuwait oil companies, and it is also successfully completed recently. So here I'm just going to explain about the what is the systematic stages of remediation process, because the oil Kuwait oil company is one of the it's like ONGC here in India. So it's a big oil company in Kuwait. So they have their own system, and after award of this project, then there is a systematic approach to complete the project. So it start with the clearance of radiology survey. That is the survey, because this site, this Kuwait oil site, is mainly destroyed due to the oil war. So that unexploded ordnance, that is like of unused bombs, must be lying under the soil or oily sludge. So it is a very no, high hazard to the human being. So first stage is clearance of UXO or radiology survey. So the survey will identify the unexplored ordnance in the site, contaminated site. So that need to be cleared. So after clearing this radiology or UXO survey, then construction of so that is a requirement. So you have to facilitate require the specific office. Everything is a very systematic process. Then carry out the environmental impact assessment and monitoring. So systematically we have to study the what are the components, what are the possible air, water, and no soil pollutants, and how it is have the impact during the treatment process. So systematically it's a part of requirement of the project. Then characterize the contaminated site and select the remediation process and remediation of contaminated site and rehabilitation of that selection site for the to prove that that site is free from hazardous material. So this project is initially awarded for 57 months. So this is a one feature, oily sludge pit. We can see this is how after restoration of this oily well, lot of huge amount of oily sludge is stagnant in open environment. These are all oily sludge pit. This is a pit. Some part of oil also came out from the refinery process waste, but mostly from the water. So these are all oily sludge pits. So this is the UOD, UXO, and radiology survey done by the third party. So how they're monitoring this UXO unexploded ordnance at the site. So they detect the several such kind of UXOs. Then based on the then after this again we have to characterize the waste to treat that what method we want to adopt it. Even that also we have discussed during last presentation. So depends on the contamination level. So first stage is characterization. So UXO everything is clear, then that site is now safe for the treatment or to proceed for the treatment. So after that, then first stage we have to select which treatment technology we want to adopt it. So depends on the characteristic and level of pollution. So here based on the characterization around more 60% of material, excuse me, 60% of material is selected for the treatment through bioremediation. These materials contain less than 5% TPH. So whatever the material which have these uh, more than 5% or more than, we can say even more than 7%, that can be, that is taken care by through thermal desorption unit. That's TDU treatment method. That is a 40% of uh, total material need to be treated. So whatever the oil, separate oil with which is which can be used for the recovery of oil, and it can be used reused. So such kind of material is separated. So once it is characterization, UXO is done, then characterization of total material has been done, then quantification and what is the concentration of pollution, everything is characterized, then followed by the method is selected, then whatever the material which need to be treated through bioremediation is separated. Then so after characterization, that segregation of contaminated material based on its total TPH, that is the total petroleum hydrocarbon content. So according to that, it is separated for the bioremediation for the thermal desorption unit. Within that, direct thermal desorption and indirect also. So according to the characteristic of pollutant, that is characterized and segregated in the site. So this is already we discussed. So Alzheimer team again after characterization, the group of bacteria again isolated from the waste contaminated site. That is here you can see in the laboratory condition, and again it is produced. So whatever the bacteria initially shows a very efficient degradation capacity. So that bacteria is selected and cultivated from tube to large scale level. You can see this is how from this selected bacteria is stored in appropriate conditions, then revived in the laboratory conditions, then it's tested for its degradation efficiency. Frequently, repeatedly, it is tested and stored appropriately. Then it gone for the degradation in shake flask. Then after that, same strain, it is again upscaled from the shake flask to large scale 13 kL reactor. Then it is pulverized, mixed with sterile corn material. Then that is again packaged under a specific conditions with maintaining the optimum moisture and temperature stored in the cold room. Then trans it and reduce the degradation efficiency. Then that produced product is transported through refrigerated truck and it is transported to the site. So we can see here how this bacterial product is packed packed in the cotton box, which is initially packed inside the polythene, sterile polythene cover. Then it is transported through refrigerated container and it mobilized to refrigerated container and ship. This shipment reached to destination. So from India, it reached to Kuwait. So this is the route and how this product is transported there. So when we come to the characterization part, after characterization, you can see the sifting of sludge and see these sludge or oily sludge are sifted and holding. It is transported to the holding tank. Then determine the remaining. So these kind of sludge is not possible to bioremediate it. So we have to separate it. So as I mentioned uh, in previous slide, so we have to segregate the waste. After characterization, we have to segregate the waste. Then after segregation, then we have to apply the product based on the contamination level. So this here sifting of this sludge, then remaining after sifting, you can see the soil with contaminated material. So how this total volume is characterized. Then after that, this site is prepared for bioremediation. So each level after removal of sludge, after removal of non-degradable material which is separated from this site is separated and it is this is a biodegradable material, that is TPH containing soil which is separated uh, in one place and based on the contamination level you can go for the in situ remediation or ex situ remediation method. So in situ method is just within the site you can apply the product to and maintain the ideal condition to remediate the product. Excuse me. Then, sorry, we are discussing about the in situ and ex situ remediation. In situ remediation process, the within the site, the product, that bacterial consortium containing alzheimer product or such kind of product is applied and maintain the suitable environmental condition to treat, and you can leave within the site. In case of ex situ remediation, you have to prepare the site. So in ex situ remediation, all the contaminated material will be quantified. Then total hydrocarbon will be estimated. Then estimated material is segregated and have to make the site preparation. Site preparation is nothing but you have to put some bottom layer, that is a thin liner. Then after that you have to place the contaminated material above the site to avoid the cross contamination with clean soil or down groundwater level. So we have to take all the safety precautions before handling such kind of bioremediation process in site. So after placing this material, we have to uniformly mix this waste material. Then in that have to estimate the zero time, that is a before application of bacterial product. You have to
मुस्लिम
characterize
नेम
the,
नहीं है, सो टिपिकल बंगाली नेम है, और बंगाली मुस्लिम भी रख सकता है, बंगाली हिंदू भी रख सकता
excuse me,
है, ये बंगाली नाम है।
professor, hello. So
Participants, please mute yourself. Thank you, sir. Sorry, sir.
yeah, thank you. Then after characterization, then we have to place the material and have to apply these bacterial product for the degradation of particular contaminated material. So how we will be maintaining this bacterial stains. So once you can see here, these materials reached within controlled condition with 2 degree centigrade. So here application, this is the prepared site where all the contaminated soil is homogenized and placed in the site. Then this packed material from India is transported in the controlled refrigerated condition and reached to Kuwait. Then with it's a very interesting process actually. So these site, even I have also worked for more than 2-3 years there in Kuwait project. And see here, more than we used to send weekly 30 to 40 tons of material oil sulfur to the Kuwait oil company. Their same our team is processing and they're recording all the conditions. Then they apply the oil sulfur. This is the corn cob material mixed with selected bacteria. So that is applied and maintain the environmental conditions. So sampling also done systematically. So initially in the presence of officials, and this is a very unique project. So we worked in. So how the field sampling and composite sample is making process is happening. Then every day there is a specific team, bioremediation team, that record the what is the quantity of oils applied and what is the nutrient, because when we estimate the quantity of TPH or TPH contamination level in the soil, again we have to quantify the nutrient level. So maintaining the nutrient is also important to keep this bacteria alive and active to degrade or eat this total petroleum hydrocarbon and reduce to the recovered level. So we have to maintain that, and the watering also. Bigger moisture is very important factor, which is again we discussed previously. We have to maintain the all abiotic factors. So watering is mainly up to 48 degree also. So maintaining the ideal temperature is very challenging. No challenging component there. So we have to make the site always moist. So we have to systematically regular interval we have to apply the water. Then tilling. So tilling is to maintain the aerobic condition to enhance the aerobic process, that is the aerobic degradation of waste material. Then PHC, that is the petroleum hydrocarbon contaminant level, need to be estimated. Then what is the microbial count, because microbial count will give you the what is the population, microbial or population in the site, along with the natural flora also will be there, depends on the concentration level. So that need to be analyzed every month or every 15 days. Then we just made a performance chart. What is the performance? What is the expected performance of that particular site, and what is the actual performance? so depends on the contamination level. These days will vary. Around, we can say, initially we planned to do the remediation up to 240 days, but based on the concentration, initial concentration, this particular bioremediation batch completed within 180 days. So but this batch is in different location, so each we have a different features in within the company. So KOC White Oil Company project. So again, here also we can see uh, this particular site is expected to complete 250 days, but again, this also more or less it reached to 240 days. So this another site, this is again, so average days for the required for the completion of these kind of TPH polluted moderately, or we can say even higher side TPH containing average of 4% or 3 to 4% total petroleum hydrocarbon percentage in the contamination level, that need approximately 200 to 250 days. So average days which is required. So more than that, if contamination level is more, then you have to maintain these environmental conditions to extend the completion of this remediation process. So these are all the few pictures about how we tried different methods to maintain the moisture, because managing the site is very difficult because of the harsh condition. But in India, it is a different situation where is very suitable environmental condition is there. So it may not require such kind of additional effort. And this is a kind of monitoring process. So our technical experts, they are all just checking and adding the bacterial load. If it is the in between, it shows that reduction of bacterial load, then you have to add the bacterial, that microbial population in the form of oils, so that it will enhance the degradation. So how this site is looking after bioremediation and before bioremediation of this lake. So this is not only because of the bioremediation process, this is a combination or different set of treatment process which is used. Then this treated material again backfilled and verified, then completed this. So each feature is completed like this, and it's handed over to the company. We can see this how bioremediation is. So this is the initial sludge pit. So this oil is separated and it gone for the oil recovery process. Then sludge is also again it is a few part. It is a undegradable material again gone for landfilling, and that moderately and slightly higher side TPH contaminated side is soil is treated through bioremediation, and it is restored this site. So then after completion of this particular process, then soil is used for the plantation to verify that this is supporting the supporting for the growth of plants. So this is since 1996, TERI is in the process of remediating such kind of high TPH contaminated waste in India as well as in abroad. So thank you.
Thank you, sir, for such a wonderful presentation. Let me check for question in the chat box. So, questions are from Abolibda. Sir, how could you decide whether the TPH reduction in Kuwait site was due to microbes or weathering reactions, since all blocks were tested in situ open field?
So that's why we made a block with control site, phytoremediation sites, and bacteria. One particular site is applied with bacteria. So it's a control site is there. So if it is a natural process, obviously you have to see the reduction in the control site. So that will confirm you that this bacteria is acting upon the pollutants, and it is degrading. So we made a control plot without any application, one plot with application of only that aeration, tilling, watering kind of thing. So another plot is without any addition, or without any activity, and one more plot is application of applied with this bacteria, selected bacteria. So then it is compared how what is the reduction. So 0 day, initial day itself, from the each plot sample has been collected, then again tested. So frequently it is tested, then we have confirmed that these bacterial applied site is effective in degrading or removing the pollutant. So then only large scale treatment is done. So this is the initial trial. So after trial also, even large scale also, again another trial has been carried out. Again this process is carried out. Then it gone for the large scale application.
Thank you, sir. There is another question. Did you also use any chemical approach along with the microbes you applied in treating wet oil spill?
No, actually, we didn't use it. Actually, from Terry side, we didn't use any chemical approach. Only we used the physical approach and microbial approach. Other than that, we tried. Still, R&D is going on. How to enhance this kind of bioremediation in different soil or different oily sludge material. So, use of with separation, even including separation after initial separation with biosurfactant, how we can increase the bioremediation process. So such kind of R&D is still going on. But it is also available in commercial application also, many places. But we didn't try it with chemical process.
Thank you, sir. There is another question from Abulibda. It is so difficult to degrade the emulsified oil spill, especially if left in the environment for long periods without taking an immediate action following these spillage incidents. Are microbial systems feasible in degrading emulsified oil?
Yeah, it is true. It is not possible in all the locations. That's why I told you in during the presentation also. We have to characterize it, and whether bacterial consortium is degrading completely. We have to assess it. If it is not, then we have to integrate with the other technology also. Example, any oil spill happen, it is not possible to apply any this kind of product directly in the in the site, spillage site. Initially you have to segregate it, separate the emulsified oil, then if it is recoverable or reusable, then you have to go for the recovery. If not, or if you want to go for the remediation process, obviously it need to be make into the solid form. Then you have to see the concentration of the material, hydrocarbons. Then we can go for the remediation process. There is a limitation for each technology, but overall, being a environmental friendly process and a cost effective process, this is comparably more eco friendly process.
Thank you, sir. There is another question from Nilesh Kanhe. Does it possible to use plasma treatment?
Plasma treatment, there is a very huge, cost wise also, and it is the limitation is there. It is not like plasma treatment and all, you can't apply in such kind of environment.
Thank you, sir. Another
I don't
question
have
from
even more idea on this, but we more of exposed in this bioremediation system.
Thank you, sir. There is another question from Abulibda. Have you tried any hybrid approach with the biological system you use? For example, nanomaterials plus microbial consortium in order to enhance degradation efficiency.
Yeah, this is now it is going on a lot of such kind of approach. We want to enhance this bioremediation process, but large scale it is difficult. I mean, there is a lot of legal limitation as well as no. Kind of limitation is there. Even cost also one of the major factor. So if it is a successful, because integrated method of biological method, even nanomaterial is also more effective in wastewater treatment of even highly contaminated wastewater, everything. It is applied, it is there, it is practically it is applicable. We in from our technological side, we are not applied, but it is applicable. We can use.
Sir, I have disconnected. That's why I'm using another device. Am I audible, sir,
Okay.
now?
Yeah. Please
Uh,
proceed.
okay. Sorry for that. Participants, if you have any other query, you can unmute yourself. If no more questions, sir, I would like to thank you for your wholehearted support in the sport conduction of this FDP, and for being with us for 2 technical sessions, and for sharing your immense knowledge on bioremediation process with using different bacteria or microorganisms, and for sharing different factors that affect bioremediation process, and also for sharing the case studies that was applied in Kuwait, and also for case studies in India's context. Thank you for also for sharing your knowledge, and for being with us for this 2 technical session. We have been greatly
I
benefited
think
out of your
somehow.
session. Thank you, sir. Thank you very much. So with this, we'd like to conclude this particular session. Thank you once again, Dr. Nantkumar sir, for your gracious presence in this technical session.
Thank you so much. Thank you so much for everyone. Yeah, thank you.
Welcome, sir. Thank you. Thank you very much.